Hi everyone. So in today's video or stream, we are going to be continue with our Odin programming series, and what we'll do in this one is we are going to explore this cool concept known as fractal tree or fractal canopy. And the main idea here is to generate this tree sort of a structure. If I open this one, so this tree like structure, and the way it is generated is quite interesting. So you can write very less amount of code and generate this particular tree, which is known as fractal tree. If you look at this particular tree, I should probably set up my drawing pad. Give me a minute. Okay, so I have my drawing pad set up, and now I can draw things. Okay, so for drawing, let's use app. Right. So the way this tree is created is very interesting. Why I say it is interesting is because see, so this is known as a branch. If back to this, remove this one. This is a branch. So this is a branch of a tree, and then we generate other branches of this particular tree. And the way you generate other branches is you use same branch and you angle it off like this, and you angle it off something like this, something like this. Now from this point you have drawn these two branches at like certain angle. So if I draw uh, x-axis and y-axis, so this is the angle which will say theta, right? So this is the angle, basically this one, this is the angle theta. So you generate it in the left direction and in the right direction. Then what you do, you take this one as a point, for example, and you generate one more on the left, one more on the right. And one more thing you will notice is the length. So the length of this branch keeps on decreasing. So length initially might be 10, then it becomes 9, that becomes 8. That's up to you how much reduction of the length that you want to do. I hope you're not facing any issues because it say the stream health says okay, we'll take care of this, right? What happens here is you generate this one, then you come here, you angle it off here, and you angle it off here. This is how you generate like this particular tree like structures. So you can see we have this branch, other branches emerging, and that's how you draw a fractal tree. And the interesting thing is you can write a recursive function. So basically you have to draw a branch, you have to angle off, you have to draw branch, you have to draw this branch, then it is a recursive function. You come here, you draw another branch, you draw another branch, and so on. So this is classic recursive piece of code, right? So this is what we are going to do today. We are going to draw it in Odin. Basically you can use any programming language that you want. In terms of library, I will be using the Raylib library. So if I go back here, so Raylib is a pretty cool library. It's simple to use library for drawing stuff. You can use something like SDL2, SDL3, that is also fine. Maybe your language has some other libraries. So there are a lot of binding, as you can see. It supports a lot of platforms, it supports a lot of language bindings, and we have C Sharp, we have Golang, we have Lua, I think this is Lua, yeah, Python, Rust, Zig, and we have Odin. So I'll start with the Odin. Okay, so the cool thing about Odin here is it has the Raylib library baked in the standard library, so you don't have to pull in anything else and then install any other library via package, nothing like that. So this is the, you can see this is the Odin project, right? And the way we use this library is something like this. So we have an example. Let's do one thing, just copy this example and start with our adventure. So I'll call it fractal tree Odin. So fractal tree Odin. We create a main.odin file. I'll just paste this example, a few things. So fract tree Odin. This is your what you call it, the title. So if you see there is like a title here, Odin. This is your title, and this is your height and your width, I believe. One cool thing is you can go to this Odin file, raylib.odin, and you can look at like all of the functions that this library basically provide. So something like it provides like a lot of colors. There is white, magenta, blank, black, and all of those stuff. The cool thing is this sort of acts like a documentation for this library, and you can do cool things from this. So what I want to see is for this method that we have init window, I want to see what is these parameters. So this is width and height. I don't know the order. So init window, so it is width and then height. So I'll just do one thing. I'll make them constants. This is my width and my height is 450, and then I can come here and use those. Okay. Now what I want to do is I want to go into that folder, do Odin run dot. Yeah. So we got a window that says congrats, you created your first window, which is pretty cool. So we have this one over here. We have some weird formatting. I don't know why. So we begin drawing, we end the drawing. So the library is pretty intuitive to use. You initialize a window. There is a loop, drawing loop, game loop, whatever you can call it. So you have a draw loop which will draw stuff after certain period of time, and how it is decided when it will draw is you set the target fps. So I'll set the target fps to 30. We don't need even 30 in this case. Yeah, so nothing will change after doing that. And this is the draw loop which checks for window should close. So while the window should not close, you basically draw things on. So I'll say I'll dot black. Do we have black? Yeah, we do have black. Okay. I don't want to draw any text. I just want a blank window. Right. So we have the window now. Now, what I basically want to do is I want to basically start with do I have access to my drawing board? Something different. So I use this. I think it doesn't have it's out of battery, but good thing is that we drew this particular diagram. So I want to draw this branch first. This is simply a line with some sort of a thickness. That is how you can think about it, right? How we can draw a line. So let's see. We see there is a draw line function over here where you can provide the start position, start and end positions, the color itself. One more thing that you can do is you have a draw line ex. So I'm not sure what ex means, but it provides you this thickness as well. So you can create a vector 2, and from that vector 2, then you can do stuff. You define a start position, end position, the thickness, the color, and so on. So what do we do over here? Let's come back to our code. Let's start with drawing like a simple line. We'll call it like draw branch. So it is a prop that doesn't return anything. What it takes is the start text, or can pass a vector 2. So start and will be type vector 2, and then we will have our thickness. Since the thickness is also changing, if you notice it here, the thickness here is more, then it starts becoming less. It looks pretty cool when you zoom in, but anyway, right, so back to our code. We want a thickness which will be float. Let's see what the thickness. So drawline ex, the thickness is f32, which is correct, and we have some other things that we want to pass maybe, and we will see as we go ahead. So what I'll do here is, after clearing the background, setting it to black color, I will call draw branch. Also, one more thing is we need an angle. So the angle initially, I think it should be, so the angle is basically this. I think I drew it incorrect. I don't think so. Okay, so the angle is, I think, perpendicular to this. So if we have this branch, this is basically I think 90 degrees, I think, because if you draw something like this particular angle over here is 90, right? So we will start with an angle 90. So start vector is start position. So I'm not sure in Odin if you define variables by what is the so this is variable declaration. Okay, it is snake case, right? So we are going to use snake case starting position with vector2. So how you can define a vector2, I believe, is something like this: vector2, and then you can define the vector2 with your x and your y. So x will basically be, you take the x-axis, x is in the middle, so at the center. So center will be something like width divided by 2, the height divided by 2, right? And what else we have? Width divided by 2, height divided by 2 will, okay, is not correct because it will center it, but in terms of the y-axis we want it to be touching the bottom part of the canvas, so it should be high. So we have the start position, and the end position will be, let's say I want to define something like this vector2, and we will have the width. So width, it was half, it will remain half here as well, right? But the height will change now. So height was like, if I, this is our ground, so height was, so this is our canvas for example, height was y. So now if you subtract something from height, it will be here. So y minus, for example, y minus 10 would be here. So here if you want to draw, right? So we will do y minus 10. Y minus 10 is basically height minus some number. I'll say 10 for now. And let's see, let's draw this thing. And we also want to pass angle, which will be 32. So both are f32. I can remove this one. And what else do we have? We have to pass the thickness, thickness of 4 pixel, the angle. And one thing, the angle is in radians, I believe. So we do have a function to convert relief cheat sheet on this one. So there is a method to degree to radian. There is a method degree radian. Okay, and it says something, but yeah, I wanted to find out. I go in here and check. We have two. How many occurrences of it? Wouldn't be able to find it this week. Let's go to the top of the page, and it should be somewhere on the top, I think. And yeah, we have this. If you see here, degree to radian. So what we can simply do is we can multiply our angle that we have over here by RL dot. Right, this is our angle. Now let's come back to our draw branch. What you want to do simply here is to do RL dot draw line ex start the end thickness, right? So right now that we aren't using the angle because I will come up with the angle stuff. One pad. Can I have connected it? Okay, this just try it again. Doesn't show my iPad. But yeah, I guess I have to deal with it without. It will be interesting stuff. So yeah, draw line ex, do this correctly. It should compile. But didn't. We don't need this. Vector2 is not a type. Do we have to do? Okay. Cannot assign value draw of f32 to invalid type. Let's say we have vector2 over here. Only one error we have, the color. Okay, we are not rl dot relive white declared there, so color ray white. Now we run this and we got, it's a pretty small line, let's say, but we have a line nonetheless, right? And okay, so we got a line, which is good. But now what we want to do is we want to have the line like some more height, and for that what I'll do, I'll say 50 over here. Now we have a taller line, and I think instead of saying 50 you can say 100, and the thickness also I believe increase over here. This still looks small, so I'll do like 200. Yeah, this looks fine too. So we have drawn a line, which is a progress. Right. So we have drawn a line. Now, next, what should we be doing is we need to draw these other lines that we have. Can I zoom? Okay. So now I have drawn this line, particular line, and my page is gone for some reason. Okay, it's back. I don't know. Now we want to draw these two lines and we want to do this recursively. So what I'll do is draw left line, draw right line, right. And how you can draw these lines is interesting. So I'm not sure if it is going to be on the left side or not, but I'll try my best over here. So now we want to call the draw branch function. The start for this will be the end now, and end left. End left is something interesting that we would want to calculate. So RL dot vector 2 right, and we will have our end right over here. So this is our end left and this is our end right. Now you want to do the angle sort of a stuff, which is interesting. How you can do angle thing is so you can basically, what I will do is angle a line 2D. Do we have any good drawing? We have some drawing. But I want the one with like sign, and I want to explain that thing. Yeah, something like this. We want to draw this particular line on the right, and we have this angle called theta. Now what we want to do basically is we want to draw this line. So if you know from mathematics class that if we have this sort of an angle, and can I erase few of the thing? Oh, I got it. So if we have a circle in the axis and this is our angle, let's say theta, then you must know there are like two formulas. One is for sine theta. Okay, drawing with this is possible, and now the application hangs. Great software experience. So I'll close this one. I'll try to explain over here. So we have this one. Yeah. So sine theta will basically be the opposite, which is y, and divided by this hypotenuse, which is the radius of the circle. And if we say it is a unit circle, the radius of that circle will be equal to 1. So basically sine theta is equal to y. And if we say cos theta, I hope I'm saying correctly, sine theta formula, we can look up at this thing. So we have this sine theta is the opposite. So opposite is y. I'm correct. Sine theta is equal to y and cos theta is equal to x. So this is the thing we will be using over here. I'll simply write here for my, so sine theta, I'll say q for some reason is equal to not x, going to be y, and cos theta is now what we want to do. So we have our angle right, and what we basically want to do is shift it towards left, right. So we want to change the x and the y coordinate for this one. Let's do for right first, I believe, and then we will come to the left. Draw the branch and right, and our thickness will decrease by some parameter, so thickness into 0.75, let's say, and the angle will also. So one thing that we haven't done is we haven't used the angle till now, but now we are going right. And for this I will need some sort of mathematics in Odin. How do we do that? How do we sign? Do we have sign? Okay. Sign. Basically it should have a math library. I believe a math library. Sign mat dot sign. Yeah, mat dot sign. Sign cos. Return the sine theta in radians. In radian. Alright, so we can use this function sign, and inside which package do we have this? 4k. So we do import math. Let's do one thing. Calculate this. So x is going to be mat dot cos f32 underscore, and what we will pass inside this is to be, okay, we need to add the particular that particular thing is you need to add the stuff to the existing. And what I mean by that, I need a good drawing. Maybe I should write, that can be a cool idea. So let's just start with this one. And so now x will be the existing x, so which will be n dot x plus this thing, and n dot y plus, it's not going to be plus of course, but I think we need a length. So instead of passing the start and the end, what we should do is we should do vector2 over here, something like this. We should be passing the length. Yeah, I just realized we should which is going to be f32. And what are we going to do? So end will now be equal to vector rl dot vector2, which will be vector2. Our end will now be calculated using that particular so x will stay the same, I believe. So x stays is equal to your start of, okay, so it's basically start dot x plus your length into whatever you have. So length into, so x was cos of f32. What does vector2 have over here? Vector2, I want to see the definition. Okay, vector2 is f32, right? And yeah, cos of the angle, I believe it should be something like this. And end dot y is going to be plus length, not plus, keep that in. And I think we need no, so length into sine 32 of the angle. Do we have something incoming? I don't think so. Okay, this is what we have for end. Let's just comment these lines for now, and first we want to draw the line that we had using the thing, and we want to change this thing. So now we don't end position length. We don't need this length, I'll say. Okay, so this cos and sine function are math dot, and this is also end dot name end. Okay, this is good. Yes, we got the line. So we drew the line, and I think we can use the length 200 maybe. Yeah, this is good. This is good. And thickness also, I think we can make 15. Yeah, this looks good to me. Now what we want to do, we want to angle things on left and right. Let's do right side first. And right, we need not to calculate. We will, our length is going to be, say, 8 maybe. We have the thickness, the thickness as well. We have the angle. So angle is something now to change, right? Do we want to change the angle? Of course, otherwise let's just not change. This will go into like infinite loop. Okay, I don't, how I can do this. So I can say iterations, or I can go till my length is 10. If length is less than 10, then we just turn yeah, so you can see the angle never changes, it keeps on. So you want to change the angle, you want to change it to the right. So that means should be what do you want to change? Okay, initial angle is 90. Let's do something like 30, but I believe this is not going to be correct. What is it? Degree to random. See, we got all the things going right, and then it goes right, right. But we want it go, so we have to do something with the existing angle. We can say angle minus C. Oh, this is good. So we have angle of here, tree. This is cool. So this is the right side. We do the existing angle that we have, which is 90. That side. Right. What else can we do? So 90, and then you let's draw the right line as well. So instead of you subtracting, you, ooh, look at this. We have the tree. We have the fractal tree, but I believe I have the length is too much. I'll change length back to 100. Oh, so this is the fractal tree that we have finally drawn, and it looks pretty amazing to me. The branch thickness kind of looks the same, so what I'll do is tune the parameter of thickness. I'll say thickness delta be something like 0.5, and instead of using this, I'll use thickness delta. I'll use thickness delta. Okay, it's too less of a thick 0.6, 0.7. Yeah, this looks good to me. So this is the fractal tree we can draw. There are like interesting things you can do out of this code. You can change this angle to something random. I'm not sure where is the random thing. So you go here, math.random, math underscore big has a random. Okay, integer random. You can do couple of things. Yeah, you can do one like pretty simple and interesting sort of a thing. You can change the angle for both of these. You can save one, keep 20 and another L. So your tree will skew this thing in my right. And if you yeah, so it's fun plan. You do 10. So yeah, now your tree is skewed. This is pretty interesting stuff. Do we have anyone? Let's see. Okay. Yeah, so this was basically it for this stream, this video. If you are watching it later on, I'll do one thing. I'll attach the, what do you say, the Fractal Tree Wikipedia in here. So this is my, this is like Fractal. This link, catch it in the description. Thanks a lot for watching. Thanks a lot. I'll see you in the next one. Bye bye.